Hi, this video is to talk about hypothesis testing for population proportion. And again, what we're doing is testing if the population proportion is higher or smaller or different than a hypothesized number. And we're going to be using sample data, confidence level, and z-scores to come up with hypothesis test. Okay, in the hypothesis test, we compare the value in the hypothesis with the value we found in a sample. Take into account the variability. This is the process of standardizing the difference between the hypothesized proportion and the sample proportion. So this is the difference between the hypothesized and the sample proportion. Are they different? Are they the same? Take into account the variability, the standard deviation of proportion of the sample proportion, which is given by this formula here, which you learned in chapters 7. Okay, so assuming, and this is just assuming, we don't need to compute this anymore. Okay, so here's an example. Over the past year, 20% of the players at the Pine Creek were women. In an effort to increase the proportion of women players, Pine Creek implemented a special promotion designed to attract women golfers. The manager now wants to determine if the proportion of women players has increased. I don't know. Has it increased? So we have the null hypothesis that has not increased. We always assume nothing has changed and nothing has increased. So if we want to test if has increased, this testing is the alternative hypothesis. A random sample of 400 players were selected and 100 of players were women. So we have a proportion, hypothesized proportion, 20%. We have a sample, 400 players, 100 players are women. So we have to compute the proportion here. The proportion is 100 over 400. The proportion is 0.25. Okay. So let me show you very quickly. I don't want to spend too much time on this, but so let's go back to my. So we have a null hypothesis that the proportion of women 20%. And we want, so in this one it's better to start with the alternative. The manager wants to test if the proportion has increased. So the alternative is that the proportion has increased for more than what? So if this one is increased, this one is decreased or equal or is smaller than equal. Okay, this erase is too big. So this one has increased. This one is like this. So more than how much? 20% over the past year, 20%. So it's 0.2. It's 0.2 and 0.2. So this is the hypothesis here. Okay, a random sample of 400 players. So I have a sample of 400 women. So 100. Proportion in the sample that are women is 100 divided by 400, which is 0.25. So I'm going to have a z-score in which my sample proportion minus my hypothesized proportion divided by this variability here. So square root of hypothesized proportion 1 minus hypothesized proportion divided by n. Okay, so this will be my z would be something like 0.25 minus 0.20 divided by 0.20 or 2 multiplied by 0.8, which is 1 minus here 1 minus 0.20 is 0.8 divided by 36 by 400. Okay, so I do this math and I get the z statistic. Okay, and the level of significance 0.5. So the steps to solve this problem is very similar to the steps I showed you before. You have a critical value approach with the null and alternative hypothesis. Determine if it's an upper lower two-tailed test. In this case, the alternative hypothesis that is higher. So if we draw, has to be higher. So it's an upper tail test. So if it is upper tail test, I get my level of significance. So if I do the steps here, just very quickly to illustrate to you step 3, let's say step 3. So I do 1 minus my alpha is 0.05. Let me see, 0.05 my alpha. So 1 minus 0.05 is 0.95. I do this because I have to enter this number in this formula in Excel. Remember? Then you go to Excel, enter this number in Excel, and you have a z-critical. Let's do that very quickly so you can see. So let me clear all this. So equal norm dot s inverse. What's the probability? It's 0.95. Where it's coming from, I computed here. This is the reason I do step 3. I do step 3 here because it's an upper tail to be able to get this 0.95, to be able to enter this formula in Excel. And now I have the z-critical. This is my z-critical. Okay, so go back to here, go back to this is my z-critical. So if I go back to here, my step 3 is z-critical is equal to 1.645. My next step is collect the sample data and compute the value of the test statistic. I did it here. I don't know how much this is. I'm going to skip this part. So I compare now this z statistic with my z-critical. Because it's an upper tail test, okay? Upper tail test. If the z statistic is higher than the z-critical is 1.645. So if the z statistic is higher and is in this region, I reject the null hypothesis. Okay, you're done with the test. Then you have the p-value approach, which has the same basically steps, and you compute the z statistic, and then you get the z statistic to find the probability. Okay, and then because it's an upper tail, you use this formula, and then after getting the z statistic, the probability value of the z statistic, you compare with the level of significance alpha that is given. If the p-value is smaller than the level of significance, you reject the null hypothesis. Okay, very similar to the other steps, and I think that there is nothing new. I'm going to stop here and prepare another videos to show you how to solve everything using Excel. Everything in this problem, I'm going to use this problem to show you how to solve in Excel.